Hello. Good.
I would give you more room for stuff. I can't see if I sit too far away. Oh, no. You're fine there. No, it's fine like that.
Well, some of this
I'm not that
I
kind of
just
guy.
hid out so that I could get stuff out, and I got stuff out. And so did anybody not get their paper back from Monday a week ago? Not yet. Okay. There's still obviously a pile here. So what happened?
Oh, you're talking about the Monday previous to last week?
Yes.
Okay, yeah, I didn't get mine.
So you...
Dan. Probably lots of pages because my writing's lots of computer paper, most likely.
Daniel McCullen?
Yes.
Speaking of which, did you send me test 1 yet?
I thought I did, but I can go back into my...
Check. I emailed you too. That's it, right?
Yes, that is my handwriting, absolutely.
So, for those of you that were here, we were going over the syllogisms ad nauseum, which does everyone ever use ad nauseum? And do you know what it means?
Yes.
It's pretty easy, right? Because we use the word nausea. Ad nauseum. We were just really, we were ready, the folks that were here. So I went ahead and we did the test. So we're a week ahead, not really 2 weeks ahead. Because last week, no one came, by the way, last week for the movie, except for me. And so I didn't watch any of them, because I just did emails and stuff. So it was fine. I only stayed for until 7:30. I figured by 7:30 no one else was coming, so I left. In any case, so we've already finished with syllogisms. So for those of you, and everyone that was here, by the way, I guess this is a FERPA violation if I tell you everybody got an A, because no one left until they got an A, right? So that's how that worked. And we can still go ahead and make sure we do that for the rest of you. It's just, you need to experience the same ad nauseum. You feel like you know how those work, so that you can do them in your sleep or whatever. They're that easy, I suppose. So we'll figure out a time. We don't really have to do them all together or anything. Just so long as at some point between now and next week, or the end of the course, whenever you get the chance, you do about 15 or more. 15 was what everyone else did. Syllogisms, mostly or invalid ones, right? So that you can explain what's wrong with them, but at least a couple valid ones. And what you end up doing is take the name of the syllogism, like AAA1, right? Any of those letters, right? A-E-I-O, right? So just take any of those 3 letters. They don't have to be the same letter. Right? They can be right, any of those 4 letters, right? I-I-I, I-O-O, whatever, right? With 1, 2, 3, or 4 at the end of it, and you have the name of the syllogism, right? So I-1 is the name of the terrible syllogism. As you know right off, undistributed middle, right? Easy. But so you take the name, and that would be all I would give you on the board, and then you would fill out the syllogism. Right, so you have all 3 statements with the figure, so the right figure. Then you would use the Venn diagrams to diagram it, and then determine whether it was valid or invalid and write that. And if it was invalid, then you would explain why. Undistributed middle, illicit minor or illicit major, exclusive premises, and if it was in the situation where you have the syllogism is valid according to Aristotle, the traditional system, but by Boole, it's not. And that would be because of the existential fallacy. Right? So as long as you could do 15 of those and turn them in, just give you an A for test 2. Yes?
Is there a final in this class, or is test 3 just on 7 through 9?
Test 3 will be just like test 2, where we'll be doing the symbolic logic. But there's a 4th test, which is just like test 1, where you just email it. So it's not a cumulative final. It's not one where you have to show up and sit for 2 or 3 hours and sweat. Just email me, and in fact, it's a give me just like test 1 was. It's already posted, I think. I might have to change. Yep, so it's already posted. If you go down here on the souls. And by the way, remember that at the end of the summer, there's a survey, a student survey, which hardly anybody ever does anymore, ever since they've gone online. No one wants to take the time to do them. Don't know why.
Oh, I have.
But if you have the chance to go on and do the student survey, I'm especially interested in finding out if you love me or not. You know, that's...
The flowers mark.
Yeah, you know, in other words, keep hiring this guy or take this, or not, and if not, why not? Like, he's too ugly, his jokes are terrible, or ought to be illegal, or, any, whatever you really think, because I would like to keep this job. It's heaven on earth. But in order to do that, students have to sign up for classes. That's just the way life is. So it's not my fault. I've seen a lot of what I think would be really good teachers, except that they're really hard and insistent on people doing all sorts of things that they believe students ought to do. And as a result, students hate them and never take their classes, and so they aren't here anymore. So it's not my fault. It's just realism. However, on the other hand, I'm always honest about my feelings about it. Education really is important. I'm absolutely convinced. The more you learn, the better off you will be. And that's just like push-ups. A few crappy push-ups aren't really going to help you that much. But if you do really hard workouts, you really do see a difference. So, education is the same way. Yes?
When are we going to learn this stuff? For test?
How are we going to learn this stuff for test 4?
Logic final.
We'll go over it.
Okay, good. I
Yeah.
was like, did we
Yeah.
go over this?
Yes, we will. We will. And this is serious stuff that we're doing now. Starting now, what we're looking at is symbolic logic. So this is the kind of logic that really began roughly around World War I, or the end of World War I. Although there were folks that were trying to do it before that. One of the main ones was Leibniz, Gottfried Leibniz. He's famous for a lot of things. One of the most important things, though, if you're ever in continental Europe, which is what, France and over, right? England's not really considered part of continental Europe. It's kind of like Alaska, right? How many of you are pissed off every time some post office place says, oh, we don't ship to Alaska, right? Because we're not part of the contiguous United States. We're part of the continent, but not part of the contiguous, because Canada's in the way, right? But England is not part of the continental Europe. don't know exactly. Ireland and Scotland obviously not either. Iceland not. You know what I mean, right? They're not on the continent. But if you're in continental Europe and you're talking about great science figures in their history, the one to mention is Leibniz, Gottfried Leibniz. As far as they're concerned, he's the one that invented calculus, binary code, calculating machines, translation systems, what else? I mean, you know, all sorts of things. If you're in England, on the other hand, thou shalt not mention Leibniz.
Why is that?
Because their hero is Sir Isaac Newton. And they actually almost went to war over this. In fact, there's a book called The Calculus Wars. So if you think I'm just kidding, obviously if there's a book about it, it must be so. So the cultural attachment to their various heroes, as far as the British are concerned, Sir Isaac Newton was like the smartest guy ever, even though he did not invent sliced bread. So he did not invent that. Anybody know who invented sliced bread?
Some guy with a knife.
Hi. Some guy with a knife? Maybe. I don't know. So, by the way, anyone know where Stephen Hawking was just buried?
In the ground.
Stephen Hawking just died
Something.
not too long ago.
Like a month or two.
Yeah.
Cremated
It wasn't that long ago.
parts of his ashes and put it in space, I think. Is that right?
I did hear something of that, but his official resting place is next to Sir Isaac Newton and Charles Darwin. And is that St. Paul's Cathedral? Anybody? No Anglophiles?
Westminster.
Westminster, wherever
He just read
Darwin.
that off my
Oh, no, 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 no.
Is that, is
It's
that,
right here.
I'm a big Jeopardy fan.
so,
I don't need to watch a memorial. Okay.
oh, that's, yeah, that would be cool.
Otto Rowe-Weeder invented sliced bread.
Otto
Rowe-Weeder.
Rowe-Weeder. Boy, now that is trivia that we ought to remember.
He was born in Iowa.
Wow, I was thinking Germany somewhere, but you know, even today, when you go to Germany and you buy a loaf of bread, it's round and has no slices. So you have to give it to a woman who can like prop it, you know, where they do, and start slicing it the way they do. Which is why I think they wear those outfits the way they do. Well,
Sliced bread's only been around 90 years.
Be serious?
When the patent was,
amazing.
his prototype was built in 1912, destroyed in a fire. It wasn't remade until 1928.
I'm going to turn this off. Go to the book. The book. You know I'm serious.
Yeah. That's exactly it. Yeah.
You forgot your book?
I've done that a bunch, and it sucks.
So we're starting chapter 7, which is titled Propositional Logic. So first we'll talk about logical operators. Translate stuff. So, let me explain. Up to this point, we've been concerned about true and false statements, and then combining those in syllogisms, and hence we can end up with arguments. we have 3 statements. And there's nothing wrong with that. That's still the way a lot of folks build their arguments and so on. But what various individuals, Bertrand Russell was one, Alfred North Whitehead was another, Gottlob Frege, another, some Italian folks. So lots of folks were involved in this, trying to figure out a more powerful system that doesn't, number one, require you to break your statements down from common everyday speech into the categorical statement forms that Aristotle used. Right? Remember, that felt really weird that you'd have to first translate your statements into AEIO statements. Now, this doesn't mean that at the base of what you're saying, or however you want to say that what you're communicating are AEIO statements. It's just that we're saving ourselves the trouble of translating from everyday speech to those, because that's a whole other step. Right? So instead, you can leave your language where, the way it is, and instead focus on the logical connectors that you're using in everyday speech. So what are logical connectors? Actually only have 3. And if you've already been doing computer codes, you know what they are, I suppose. The main one is and. We use that lots of times, all the time. In fact, if you like doing crossword puzzles, notice that they've decided, the crossword puzzle makers, that and is the most common connector. So if you ever get the clue, most common connector, 3 letters, it's and. In our symbolic system, we're going to use the dot. And that's even referred to simply as the dot operator. The dot operator. And it means and. So what does and mean? Math, right? No, I can't. Oh, sorry, my mind is not Dwayne. Dwayne was over here. You're Dwayne. Reese.
Yep.
Reese. Okay. So what does and mean?
So if you're continuing on to something, if we were to give a statement, say, my dog is very playful, and you're continuing on, you're adding something on to what you just stated.
So as far as like logic operators go, and if one thing's true and the second thing's true, then the result is true.
Right. So the easiest way for me to look at it is with a truth table, which I believe in the chapter will come up later. So I'll scoop, take that truth table and throw it here to explain what this is. If I have a statement on the left, which is an AEIO statement or a statement that's true or false, even if I haven't translated it into an AEIO statement, but it could be. Right? So if I say something more confusing like, the walls in this room are smooth, whereas the walls in my house are rough, or something like that, right? So what have I got? I've got 2 A statements that I conjoined. I didn't say and, I says whereas. But what does that mean? It means I'm saying both of those statements are true. So if I have statement, call it P, it's just a variable for any true or false statement, but not for excitement or a question or an imperative or a moral judgment, because those are neither true nor false. Right? Instead, it's just a true or false statement. And does that look like a Q? How would you draw a Q? But
There you go.
that's good? Okay. So P and Q. Right? And if I use a truth table and say, well, P, I'll rewrite P. The nuns would be so mad at me because my fonts are so screwed up. Okay, so P. P can be true or it could be false. Now, that's actually kind of weird because any statement you pick is either one or the other and not one or the other. It's one of those, right? I might not know what it is, so I might say the walls in the Cars supermarket are 10 feet tall. Actually, I don't know if that's true or false, but we could go over and measure it. And if they're all the same and it's not ambiguous, we would probably say, oh, it's true. We would know. It's not the case that it's true or false. It's just that if I'm talking about a variable, that's a placeholder for any statement that I'm saying has the characteristic of being either true or false. That's what I mean by that, right? Sorry, that kind of ambiguous does choke people up, everyone. But so this is a variable. It's not an actual statement. It's a placeholder for a statement that could be true, could be false. But since I'm not actually talking about a specific statement and it's a variable, it could be true or false, right? Q is just another placeholder, another variable, so it could be true or false. But now that I have two statements, both of whom can be true or false, I actually have 4 possibilities I have the possibility where both of them are true, where P is false and Q is true, where P is true and Q is false, and where both of them are false. That's all 4 logical possibilities, right? What this dot operator means is that this whole statement here will only be true where both the left side and the right side are true. In all other circumstances, that means it will be false. So a logical operator has the ability to hold more than one statement that has true or false potential together in a more complex, a compound statement, right? And the meaning of the dot operator tells you under what circumstances this compound statement will be true or false for any group of statements. So your shirt is blue, your shirt is red. Both of those are true. Everybody agree? Yes? That's okay, right? Well, so that statement was true, right? Your shirt is green, your shirt is red. That's false, right? Oh, yes, right? Green, red, right? Blue, green, false. See how this is really easy. Seems oddly hard to explain, but on the other hand, it's actually very, very simple, right? Okay. And yours is green, yours is yellow, both false. False, right? You can see how that works. So, pretty easy. N means both the left side and the right side are true. Or you're lying about something, or you're wrong. You might not be intentionally lying, right? You might just be wrong. I don't really know how tall the ceilings are over in cars. What if I said the ceilings are 10 feet high in cars and 20 feet high in Freddy's? Both of those could be false. I don't know. I just know that the Freddy's ceilings seem to be higher than out, right? Depending on where you are in the Freddy's, because they have some false ceilings in a couple places to make the place look homier around the jewelry shop and things like that, right? Do you ever wonder why they did that? You look outside, you could see that the whole ceiling from one end of the building to the other is all the same size, but you go in and they've got these artificial ceilings to change the atmosphere around different areas. Do you ever wonder why they went to the added expense?
I don't know about Freddy's, but back home in Massachusetts, all the local Stop and Shops and Shaw's, which is the two local chains, their organic or natural food sections, they all have to have wood grain floors instead of tile floors, and they feel natural,
Make it look
homey.
more natural, yeah. Okay, so that's N. Right? I did that 2 weeks ago. It's still there. So the next one is or. We use or all the time, just as, right? That's part of our language. Or we use the wedge. So we call it the wedge operator, or the V. Yeah, it looks like a V. Whatever, right? Pretty easy. And I'll do the same thing here. Because with two variables, we have, again, 4 logical possibilities. And what the wedge means is where both the left and the right are true, the compound statement is true. How many of you agree with that? Everybody? Okay. Some people, when they look at this, they feel that the only situations where the or should be true is here and here. But they think this should be false. You know anyone that would do that? So there is a difference, yes?
The people doing that are probably confusing XOR with OR.
Okay, so what do you mean by XOR?
So XOR is programming shorthand for exclusive OR,
Uh-huh.
and that would be if one but not the other.
Okay, so we do call it the exclusive OR versus the inclusive OR. In logic, the wedge operator is always inclusive, which means that this is also true. You can have both the left and the right. It's interesting because I've met students that were absolutely adamant that it should not be true under those circumstances, because they grew up using the word or, meaning you can have this or you can have that, but not both. It seems to be a cultural situation, that there are families that are like that. And the thing is, I can imagine situations like when we first moved up here in the Army. That was 87, I was in E6, and the Army was paying for our food for a family. We had 3 kids at the time. And so if we went to the Royal Fort, which is no longer there, right? Royal Fort was
Northwood Hall.
yeah. So you go in there, and I could tell the kids, you can have, eat whatever you want for dinner, and then, for desserts, you can have peach pie, or apple pie, or cherry pie, or ice cream, or cake. And what I meant was, you could have all of it. Because it was one price for everything, right? So I just paid their ticket, and they could just eat and eat and eat. And remember, that was great for hobbits. Hobbits, when you have to feed, hobbits, little hobbits take a lot of fodder, and everything. So that was the inclusive or. I'm using the inclusive or when I say you could have this or that or that. Yeah, and you want both of them? Fine, that's good. And it annoys the heck out of people though if you're in the store or someplace and they say, do you want paper or plastic? And you say yes. It annoys the heck out of them because they want one or the other. They don't want to hear you don't care, right? Which is basically what you mean, right?
Yeah.
Yes.
Yeah.
Right. Yeah, they look at you like startled, like, oh, that's not an answer that I was expecting, right? Because they were looking for the exclusive or, which means just one or the other. You can't have both. Logic has an argument that says that the more primitive use is the inclusive one. Now, if you can figure out why this would work, but if you use the inclusive or, then you can express the exclusive or in your symbols. But if you use the exclusive or, you cannot use the inclusive or. Thanks for mentioning that in code you actually have a character now that is for the XOR. I've never heard of that before. It's pretty interesting. But the argument is, because we have still one more logical operator, and that's not. Not. And not strikes me as, of course, slightly different, because you don't think of not as being in between two statements. In fact, you don't have P not Q. That's not how it works. That's grammatically incorrect. Doesn't mean anything. But I can have not Q. And not Q in that case. So wherever I have Q here, if Q were true, not Q would be false. If Q were true, not Q would be right. I've got 4 of them, so I keep that. But if Q is actually false, not Q would be true. Okay. So that's how this works. That's literally the meaning of not, which is the little tiddly key, tilde key up at the top left of most keyboards, the QWERTY keyboard type. So that's our logical operators. This one, of course, can be more complex. So I can have it in a situation where there's more here than that. So for example, if I have P and Q, and P and Q is true, false, false, false. Not P and Q, I have the parentheses around the whole thing, takes this and makes it the opposite.
Question.
Of course, all of these can get more and more complex. It's the idea of it. Machines can have a field day with this. You have all of your statements there with the truth table saying what the various true or false statements are. And the computer can look at these and knows exactly what these each mean, so that it can figure out what each line will be under any circumstance. Unless you screwed it up, in which case the software will tell you that you screwed it up and show you what line you screwed it up in so that you could fix it. Right. So obviously this symbolic system ended up being the precursor to computer coding. It wasn't created for that reason. It was created in order to try to make human languages more powerful, more accurate, so that you could be more accurate in your essays, and so on and so forth. Not sure how much that really helps in all of that. You can use it to translate those things, as we'll see. But what we're going to get out of this system will be the rules that we can think correctly by. Because once we have a tool like this, we can start looking at those rules and figure out how you can figure. Because you might not think of it, but these are all the options we have when we're thinking. I feel like we're much more complex than that, but when you get right down to it, you just have these three operators and combinations of them. So we'll have, besides and, we can also have a horseshoe. A horseshoe stands for if P, then Q. And this will be true, the whole compound statement will be true whenever the right side is true. It will only be false if the left side is true but the right side is false. So the only place where this turns out to be false will be right here. Because if P is true, then Q is false. That whole thing turns out to be false in that circumstance. All the other ones, oops, that's the third one, turn out to be true. If P is true, then Q is true. That's true. If P is false, then Q is true. Well, it's still true. If P is true, but Q is false, you can see, well, what you're saying is if P, then Q. Well, this will be the one circumstance where that would be false. And if they're both false, it's still true. So, for example, my example I think of when I do this is if I tell my son, if you take out the trash, I will give you a quarter. So he takes out the trash. When he comes back, I give him a quarter. He's happy with that. That's what I told him I would do. And I'm also happy because now the trash is out. Right? That works well, right? If, on the other hand, he doesn't take out the trash, and he comes back in and I see him and I say, here's your quarter, Chris is not going to look at me and say, but Dad, you don't owe me a quarter, I didn't take the trash out. He's going to take the quarter and go, because he just got away with the quarter, without having to do it, right? So he's not going to say, Dad, you lied to me. Right? If, on the other hand, he does take out the trash and he comes back in and says, I took the trash out, where's my quarter? Not going to give it. He'll be furious, and rightfully so, right? Because I promised to give him a quarter if he took the trash out, and he did. If, on the other hand, he doesn't take the trash out and I don't give him a quarter, he's not going to complain either, because he just totally ignored me and I ignored him, right? So that's, I don't know if that's a good example of a if P then Q, but what's interesting about this is I look at this, P or Q, get rid of this here, and I put not the case P or Q. That changes this. Because if I have P, and P is true, not P will make it false. But I have Q, true. If on the other hand P is false, not P will be true, but I have Q is true. The circumstances in the third case, if P is true, but it's false, then it's false there, and Q is false. And if both are false, well then this will be true, and this will be false. So, false or true, as long as one of them is true, the whole thing is true. So in this case, it's true. In this case, both sides are true. In this case, both sides are false. So the whole thing is false. And in this case, it's true. So the only place where this compound statement is false is the exact same place as where this one is false. Which means that this statement and this statement are logically equivalent. Which means that this symbol here, the horseshoe, is unnecessary. And some systems don't even use it. The reason that our book uses it, and a lot of books will use it, is because we use if-then statements a lot in our everyday speech. And so they've added an extra symbol, which is more for us to remember, but it's also more convenient. It's not necessary, though. If you're looking for the simplest kind of system, you only need the and, the or, and the not. In fact, you can actually do away with either and or. You only need the not and one or the other of them. It's just that it becomes very, very lengthy in order to translate some of our everyday speech. But you can do it. Does that make sense? I've never tried figuring that out. I've just read that people figured that out. Our system our book will use more symbols than absolutely necessary. It's more convenient that way. And so we use the horseshoe, we call it if-then, or the horseshoe operator. Some other fonts will give you maybe that kind of symbol. The reason you see, I think, the reason you see so many different kinds of fonts in symbolic logic systems, I think is because of the way the internet and computers evolved, that they were basically trying to figure out symbols that everybody could use, and as a result, different symbols came out of that. And they're still evolving. But you'll be used to them just by learning one. When you learn one, you realize, oh, I know what that is. You'll figure it out. I don't know how that works, but we do.
I think it's kind of nice to have the horseshoe symbol as well, considering the fact that you're trying to associate it to how you talk or how you're using a logical argument. Trying to translate what you're saying into a not P or Q way.
Feels unintuitive.
It does, yeah.
Especially if you're used to the exclusive or.
Yeah, when you were talking about when I first walked in, I was in agreement because I've always thought the same way. Whenever you use the word or, it was exclusive.
Yeah, it's odd. If you think mom says to her daughter, if you clean your room, you can go out. Have you ever heard that expression? Something like that, right? Basically, mom says you can go out. If you clean your room, then you can go out. It's not the case that you clean your room or you go out. It's equivalent, right? So, oh, thanks, Mom, and you go out. That's exactly not what Mom wanted. In fact, the problem is what Mom said. Mom shouldn't have said, if you clean your room, you can go out. What Mom should have said was, clean your room. Because that's what Mom really wanted. She was dangling me, you could go out as a please clean your room kind of thing. But what she really wanted was clean your room. But by putting it in an if-then statement. Now, there's alternatives, another alternative, and I just used one here. Because this I put up here as is a sign of equivalence, right? That means this, under all of its circumstances, is exactly the same as this, right? So then it's equivalent. Well, what does this mean? I didn't define this, right? This means if and only if. In other words, I have a situation where I say if P then Q, and if Q then P, this whole thing is equivalent to if P, I'm sorry. P if and only if Q. So I'm using this symbol to define this symbol. None of that's supposed to be fair. Right? But in other words, I don't need this. I could just double up my expressions in everyday speech by saying if P then Q and if Q then P. So Mom could have said, if you clean your room, then you can go out, and you can go out if you clean your room. Right? Then what Mom is saying is, going out only happens when your room is clean. Which could have been what she was also saying, right? I'm just thinking that clean your room, or wait, P was if you clean your room. Right? Clean your room. Of course, what that really would be an imperative, which would be neither true nor false. Clean the room. So examples can be a pain in the butt. Right? So let me go look at the book, because I don't want to jump through what might seem the easiest way for me and screw everyone up. Joe,
are those saying the same thing? Where
this?
If P then Q and if Q then P, are those saying the same thing?
No. They are not.
So if P is cleaning the room and Q is you get to go outside, that's saying if you clean your room, you can go outside, and if you go outside, you can clean your room?
Right. In other words, they're equivalent. I'm saying that they're equivalent. You only get one if you also got the other.
Mutually exclusive. Mutually exclusive.
Yeah. So they come together. Clean the room, and then you can go out.
They're equivalent but not the same.
They're not the same,
But they're equivalent.
but they're well. So logical equivalence. I can have Tabasco sauce is orange. Ketchup is orange. This might not work. I'm trying to think. You know, these are two statements. They're not the same. They mean different things.
Mayonnaise and sour cream.
I'm not sure that they would be logically equivalent, though. Because can you have Tabasco sauce that's not orange?
Put food coloring in it, sure.
Yeah, there's jalapeno kind.
Shoot. See, I knew something was screwed up. It's hard to think of stuff like that on the spot. But no, we'll see. We'll see. There are instances where you can have logically equivalent statements, but they're not. They don't mean the same thing. You're either Paul or you're not Paul, right?
You could say that to anybody.
You could say that to anybody. But if I say you're either Mary or you're not Mary, that's different. It means something different. But notice that they're both always going to be true. You're
Right.
either Mary or you're not Mary.
Right.
Right? You know, so they're logically equivalent statements because of the form of the statements, but the meaning is different. Did I answer that well? Does that make sense?
I think in regards to the original choices for P and Q, which was you clean your room, then you go outside. I think what part of the confusion is since you swapped the two phrases, but it doesn't make it the same, but logically equivalent. I think that's where the confusion is, and I think correct me if I'm wrong, what we're really looking at is that those two statements are independent, but at the same time relying on each other when it comes to the argument.
Yeah, I
Because
don't
you can't
intend for
have
there
one
to
without
be
the other.
a causal sequence there. Because if I drop my cup of water, it will spill on the floor. That's not in the same sense an if-then statement that I mean in this case. So that can be confusing because we're not talking about cause and effect. We're talking about order of statements, basically. So I mean, if, but gosh, we use it mostly in cause and effect, don't we? And yet we're not really talking about it that way. I mean, you get weird things in the logic book. For example, if Hillary Clinton is Secretary of State, then the moon is made out of green cheese. Whoa, no cause and effect relationship there. Period, right? But they'll pick statements like that because they don't want to make it look like there's a cause and effect relationship in the statement. Because then you'll think, oh, if we keep throwing out plastic bags, the ocean is going to be covered in plastic bags. Cause and effect relationship, right? And that's not the logical relationship that we're talking about with this. So we're not trying to talk about cause and effect relationships.
Well, one of the examples that they have in the book is if my dog is a poodle, then today is Monday. And those have no relation to each other at all.
Yes, exactly. Because you can see there's no cause and effect relationship there. It's exactly the weird kind of statement that they'll put in the book to make sure that you're not thinking in terms of a cause and effect relationship.
So perhaps to better understand this statement, which of course it just sounds kind of ridiculous, if I were to say that I had a different dog every day of the week, would that change it to where it would be like a cause and effect? That wouldn't change it, would it? But it would help you understand better perhaps the statement that it's referring to.
If this is Tuesday, then this must be Belgium. That was a title of a really hilarious movie. Because the group were traveling to a different country every day of the week. One of those goofy, quick tours where you get so confused when everything's going so fast you can't figure out where you are. And it's basically, if it's Tuesday, it must be Belgium. That's the schedule.
Gotcha.
So in that sense, that was a cause and effect relationship that they're,
Okay.
and you don't want that.
Right. So if I were to say that, then that would bring it into a cause and effect.
Yes.
Okay.
Yes.
So you do need to just keep it completely separate.
That's why.
Not really
That's why
have
the book picks such weird,
a reason for it. Okay.
weird statements as examples. Okay. So, just to add even more confusion to this, starting on page 308, they're talking about logical operators. They start off by talking about simple and compound statements. And that can be confusing. Remember, the simple statements are A-E-I-O statements of the kind that we talked about in categorical syllogism. But so I could have Harrisburg is the capital of Pennsylvania. Wednesday is hump day. That means you're over the hump, so it's downhill the rest of the week.
Like the camel. Hump day.
Hump, yeah, like the camel. Yeah, they
The
use that.
camel
The
video.
camel. Did the camel come in?
Okay.
A couple.
You want me to text you whatever?
They give us bags though. They give
Yeah.
bags.
They're the ones that always come out.
Hey.
They're effective,
Like
so-
that.
Commercials sell the product.
I have that guy still have cars.
Well, obviously don't appreciate.
They're going for an hour, probably take a break.
I used to have a living room full of geckos there. They were dumb. They stand there on the wall and look at you, and you're looking at them, and they're looking at you like, you can't see me.
Been there. I hate it.
It's just dumb, because I've got a big lizard on my wall.
I don't understand that does that. From the shop. You know, not with that now. He's under the inside. But he's not dead. He moved.
Grilled hamburgers taste delicious.
Yes, they do.
You know, he probably shouldn't have used that one, because that's a matter of taste. I'm not sure that that's true or false. You should just have true or false statements for it. Detective novels make great movies. Oh, you shouldn't have used that one either. I don't think he was thinking about that one. Now he makes some compound statements. It is not the case that drinking hot coffee reduces sweating. So it's compound only because you put the negation sign there. So that's basically not the case. I'll say drinking coffee. Just use a capital letter for it, right? Hamlet is a tragedy and Kung Fu Panda is a comedy. So that's H and K.
And it's an and statement. Can we go back to the first one? Would that not be an if and then statement?
It is not the case that drinking hot coffee reduces sweating.
Right. You drink hot coffee, then
What we're looking at here is
is just the
drinking hot coffee reduces sweat.
Okay.
Not,
Okay.
right? No, that's a culturalism.
Yeah.
You notice that? People will say something and they'll just say not. It's
Yeah.
just another way of saying it is not the case that. But a sign of you having had too much education is that you will talk to people and say, it is not the case that. So remember that phrase. It automatically elevates your status in the academic environment. You guys could be laughing at that. I've got a bunch of those phrases if you need them.
Funny.
Ad nauseum. My favorite new one though is carpe, not carpe diem, right? Seize the day, right? But instead, carpe hilaritatum, which I believe means seize the joke. Is that funny? It's a real word, hilaritatis. Means funny. So you could say though, if you drink hot coffee, then you sweat. No way. Yeah, it increases it. Right. So increases sweat, and that would be a cause and effect statement. Let's not do that one. Because that would just make even me more confused, right?
It sort of looks like it's trying to say that the symbol, the tilde, goes before the thing. It never goes in between the two. Here or the two.
Well, it doesn't by itself. I could have it, say, in this circumstance.
Oh, okay. This is the mayonnaise jar for me, or the pickle jar. Yeah, I loosened it for you.
So I can have not the case P or not the case Q.
But not just P, not the case Q,
No.
correct? That's
I
what
have to have,
That's the way it looks.
this is not the kind of operator that connects. It always negates whatever follows it. But we'll have some exercises where you can see what doesn't work in the way you write. But what they're doing here is pointing out that you can just use capital letters, A through, what's the letter that comes before P?
Oh.
Oh,
Up to O. So you can use capital letters up to O. There's supposed to be a rule, rules on which letters you can use for different things. Because P, Q, R, S, T, U. I'm not sure if V is included or not. Those are the variables. The X, Y, and Z we will use as quantifiers. So they're kind of reserved for something else that we're not going to do tonight. And capital letters you use for predicates when we get to that part of symbolic logic. So notice they're normally not going to use capital letters the rest of the book. So it's just introducing this, that they'll use capital letters to say that we can have a true or false statement, and we'll give it a capital letter to represent it, like Hamlet is a tragedy, H, capital H. So it's really just a way of abbreviating statement. Like if you were in the court and you were trying to quick write down everything that was being said, just write H. You need an index that says H stands for Hamlet is a tragedy. Is Hamlet a tragedy? Hey folks, have read Hamlet.
That's a long time ago. I think it's quite a while ago.
I think there is. If I remember correctly, it's been a long
Was my
time.
face red? I'm sorry.
It's been a really long time.
I remember even reading Hamlet to my kids, where like there was a pig that was, you remember? It was a kid's book, Ham. No. Okay, Kung Fu Panda, comedy? So, K. Don't they have Kung Fu Panda 3 or something yet?
It's all over now, trust me.
It's over?
Yes, it's all over. There's gonna be no more.
Years ago, there used to be only 3 Star Wars movies.
Yeah, there used to be just 3 Ice Age movies, and then they just had to make.
there used to be one Incredibles.
That wait was worth it. Okay.
More Harry Potter coming your way.
Oh.
So H and K. So all they're showing at this point is we can have these compound statements represented by uppercase letters, capital letters, to stand for the simple statements, H and K. The main thing is notice that N is there, so they're sneaking in these logical operators for you, either C or G. You could just say C or G. I don't know if you always use either or not. If I, then R, etc. So the operators, notice we have the tilde key, the dot operator, the wedge, the horseshoe, and the triple bar, which is also referred to as the phi condition. Notice it's used to translate. It is not the case that and there's actually lots of different words that we use for n. So but, as well as, and you think of maybe 15 or more different words that we use that basically just mean n. For wedge or unless, horseshoe, etc. So you could use them and you end up with not D, H and K, C or G, if I, then R, G, if and only if G. So, moving on, 310, negation. Negation. We can just say not. So not the case B, not the case G, not the case H. Conjunction, that's the dot operator, means both the left and the right have to be true. And the or is also referred to as a disjunct or disjunction. Right? Notice it explains the difference between inclusive and exclusive use of or. Conditional statements, page 312. Lots of varieties of this. It's probably the most confusing of these different operators. Every time P then Q, each time P then Q, all cases where P then Q, anytime P then Q, in the event of P then Q, on condition that P then Q, given that P, etc., etc. And you have a difference between if and only if. So notice you have to figure out how to be very specific again on what you're translating. Little plug here at this point for sufficient and necessary conditions. You'll see this again if we actually ever get to the science chapter. Sufficient conditions are the conditions when you will have the event occur. Necessary conditions are all the things that are necessary for that event to occur. Just because you have a necessary condition doesn't necessarily mean the event will occur. You have to have all of the necessary conditions for the event to occur, and that's the sufficient condition. So sufficient is the one that's all-inclusive. Does that make sense? If you live in New Jersey, then you live in the United States. Mike, well, you might not think so. How many of you have ever been to New Jersey? Which way? That they've been there, or that New Jersey is? People are really picking on New Jersey today too. You notice? On the internet? Somebody said, boy, it's been really sunny lately in New Jersey. 5% tax.
Like 2 blocks back from the beach. It's not
Got a tax sunshine.
Yeah, it's like a 12-bedroom house, literally. 5 floors.
Pretty bad.
I think it's bedrooms.
So that's the main, I don't know why they really threw that in there. By conditional,
It's not like
compound statement consisting of 2 conditions. So if, so they've got an example here, S then I, and if I then S. And you could replace that whole thing with just S or I. So we have some exercises.
show.
Page 315. Translate them into symbolic form. So either it will rain tomorrow or it will be sunny. They give us rain or sun. The food in that restaurant stinks and the portions are too small. So you might say stinks and small. What do you want for small? You can make up whatever you want. Tiny. Your face is not cold, or your what? Your ice is not cold. Is ice or not cold?
Yeah,
What do they
not
use?
water, right?
Pardon?
Maybe not cold, right?
Not cold.
Yeah, that's not ice.
What page are you on right now?
Well, if it's not cold, it's not ice either.
Oh,
I think
Mount
on- I think
Marathon,
311.
when sliding through that snow, it was
not
not
cold.
cold, it felt great. Because it was so
My
hot.
stock portfolio is weak, then I'm losing money. You can do these. Too many of these, actually. Some of the more boring stuff. So compound statements. I'm looking at page 319, and they have a phrase here that says well-formed formulas. Actually put that in, what's that called? WFF. It's not an abbreviation, it's a anagram? Acronym? Acronym. That's right. So, WFF, well-formed formula. And what that means is if it's a well-formed formula, the computer will understand it. If you've not written it correctly, the computer will barf it back at you and say, or something of that sort, right? So, we have examples of well-formed formulas, P and Q. P or Q. If P, then Q. P if and only if Q, etc. We can have parentheses, as I've already used in a couple places, right? So for example, I can say P or Q, then not the case R. S and P or Q and S. These are all well-formed formulas. The computer wouldn't have any trouble with those. Little profile here about the Stoics. Stoa means porch in Latin, I believe. Maybe it's Greek. But what they mean by porch are those, where the columns are all in a row out on the front of a building. That's a porch. Those are referred to, it is Greek, so it means stoa. So,
Portico is the same thing.
I guess so, yeah. But it's called that because the Stoics taught out on the porch. So their school became known, Zeno became known as a Stoic. And they were supposed to be good logicians, but not only that. So they're going to give you some rules here. The dot, wedge, horseshoe, and triple bar symbols must go between two statements. So I can't have PN with nothing, or Q. I actually hear that in everyday speech every once in a while. Or what, right? Ever hear people make that,
Or
right? You know, they say things like that. Rule 2, page 320. The tilde goes in front of a statement that is meant to negate. Notice there's examples on that page 320 of not well-formed formulas. So P negations doesn't mean anything. P or Q negation doesn't mean anything. And the only thing wrong with not the case S and P not is the not at the end there. Rule 3, the tilde cannot by itself go between two statements. Rule 4, parentheses, brackets, and braces can be used to eliminate ambiguity. And depending on the book, I think, does he use brackets? I forget. Depends. You have some books where they will make them bigger and bigger. So if I have da 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 da, and inside that I have another, make sure you have them even, etc. Right? Some books will use, if you have parentheses, then they'll use brackets. And then after that, then they'll use these kinds of things. But that's more expensive to do because it takes more than a line in your font, so it makes the book more expensive. Funny how that kind of stuff makes a difference. But notice what he seems to be doing is just using parentheses inside of parentheses. So try to keep track of how many parentheses you use, or you get confused. Exercise 7B1, I could ask you to do number 10 is the quiz question. And what we're doing is determine whether it's a well-formed formula. And if it isn't, determine the mistake made.
Is that quiz 2?
The number
Quiz
number
one.
10 on 323.
Number 10
Is it more done?
on page 321.
321. Okay. I'm looking at 323.
No, because of that little tilted one, right?
Tilted thing.
No, I'm looking wrong, because that's, the V is not capital.
But it goes, not the case P.
The V not R is the issue.
That's what I thought, too, but-
Huh.
Yeah, it seems to be not saying anything is changed. So it's not giving looks like he's explaining it.
I wasn't going to explain it. I was going to say we could take a break.
Okay.
I was just going to put it there.